will give you a good context around 2 points now. Don't worry. Okay, cool. So this is problem number 88, merge sorted array. It's marked as an easy problem, and I would also rate it as an easy problem, but it is one of the most famous questions, and it will give you a good context around two-pointer algorithms as well. What is the question? Right, before we go to the question, if you see what all companies it has been asked in, then you can see n number of companies, including Facebook, Amazon, Microsoft, Google, Adobe, Intuit, Goldman, Walmart, TikTok. N number of companies have very frequently asked it. What is the question? You are given two integer arrays, nums1 and nums2, sorted in non-decreasing order, and two integers m and n. Okay, so you have been given two integer arrays, and you have been given two numbers which represents the size of the array. See, two numbers m and n representing the number of elements in nums1 and nums2. So m and n represent the size of the array, and nums1 and nums2 is sorted in non-decreasing order. Non-decreasing order means ascending order, right? Merge nums1 and nums2 into a single array sorted in non-decreasing order. What you have to do is you have to merge nums1 array and nums2 array such that they get merged into a single array which is sorted in non-decreasing order, right? Okay. The final sorted array should not be returned by the function, but instead should be stored inside array nums1 to accommodate this. Nums1 has a length m plus n, where m is the first m elements which denote the element that should be merged, and last n elements that are set to 0 and should be ignored. Nums2 has a length n. Okay. So let's try to understand what the question actually says. Okay. So in the given problem, what we have is we have two arrays. We are solving merge two sorted arrays. We have an array nums1 and we have an array nums2. Nums1, nums2. Okay. Nums2 is of length n. Okay. Let's get some elements for nums2. Let's say 2, 5, 6. 2, 5, 6. So here n is equals to 3. N denotes number of elements in nums2, right? N denotes number of elements in nums2, right? Okay. And nums1 is of length m plus n. Okay. Nums1 is of length m plus n, where the initial m elements are actual elements, and the later n elements are all zeros. These are all zeros, right? What you have to do is you have to merge these two arrays such that all the elements of nums2 are merged inside nums1, and these 0, 0, 0 should be replaced by the elements of nums2. For example, the final answer of this question is that you are going to update nums1 such that it becomes 1, 2, 2, 3, 5, 6. The length of the array still remains m plus n. Okay. So you can say that in the nums1 array, you have been given n arbitrary, or I would say n extra positions. You have been given n extra positions where initially everything will be 0. You can, for the time being, avoid all of these. Where are these positions going to be used? These positions are going to be used for the place where you are going to merge the answer of nums2 inside nums1, right? Generally, if you see people solving merge two sorted arrays, like if you see apart from LeetCode, generally what is given to you is you have a nums1 array, you have a nums2 array. The nums1 array is only of length m, nums2 is of length n, and you have to return a new array. You have to return a new array of length m plus n. But here they do not expect you to return a new array. They expect that whatever is the data of this new array, you populate it back in the nums1 array only. This is just done to make the question slightly complex, but it is not going to harm anything for us. Okay. So for, I would say, easier understanding, we will do one thing. What we are going to do is we are going to assume that our nums1 array is only of length m, nums2 array is only of length n. Okay. Let's take the examples. 1, 2, 3, 2, 5, 6. 1, 2, 3, 2, 5, 6. Okay. For easier understanding, we are going to just assume that. And what do we have to do? We have to merge the two sorted arrays in a new array. Okay. Now, how can we actually solve this question? Can I say the new array that you are going to create, let's say the result array that you are going to create, should be of length m plus n, because all the elements of nums1 plus all the elements of nums2 are going to be part of this array. Can I say that very easily? Okay. Now, this m plus n length array is also going to be sorted. This is also going to be sorted in ascending order. That is also something that we know, right? That this is also going to be sorted in ascending order. If this is also going to be sorted in ascending order, then can I say on the zeroth index of result, we will be having the smallest element, right? Can I say that? Because it's a sorted array, right? Because it's a sorted array. So we will be having the smallest element altogether. Now just think about it. What will be the smallest element among all of these elements? Can I say the best candidate to become the smallest element will be either the smallest element of nums1 and smallest element of nums2, right? For example, let's say this is 1, 4, 7. This is 2, 8, 9. Still, you can see that best candidate is going to come up from the smallest element of nums1 and nums2. Can I say that? Right? So what if I keep a pointer I on nums1 and keep a pointer j on nums2? Do you know what this I and j represents? I and j represents the best candidate for the current position, that is k of result. Okay. So I and j represent the best candidate elements for filling position k. Okay. K is the pointer on resultant array. K is the pointer on resultant array. Okay. Now we have to fill the 0th index. The 0th index will be either coming from the I and jth index here. And how you will check? You will check which one of the two element is the smaller element. You can see one is the smaller element. So one is going to come up here. Right? And now you can see we are done with one. If we are done with one, what we should do is we should move I ahead. Why? Because the decision for the kth index is done. K will also move ahead. K will go to index 1. Now, who are the best candidate for the first index of resultant array? On the first index of resultant array, you will be having the second smallest element. Now, who is the best candidate to become the second smallest element, guys? The best candidate to become the second smallest element is either the second smallest element of nums1 or the smallest element of nums2. Why? Because this element lost the battle with the smallest element of nums1. So this element is pending, and we know that now wherever I is pointing is just greater than 1. So everything to the right side of I and everything to the right side of j is definitely going to be greater than these two elements. So the best candidate for the second smallest element of the resultant array is going to be either the index I or the index j. Can I say that? If that's the case, then we will compare. Is 2 less than 2? Right? You can see both of them are equal. So I can put anything in place. No worries. So let's say again I will put I. So I'll move I ahead. I'll put 2 here. And this element is also done. K will also move ahead. Now K points to index 2. Okay, cool. Now again, you have to fill the third smallest element of the resultant array. Who will be the third smallest element's best candidate? Either this element or the element which lost the last bet. Can I say that? Among these two only, we will get the third smallest element. Is 2 less than 3? Yes. That means this element is lesser than 3. So this is the best candidate to become the third smallest element. We go 2 here and j comes up here. Now, again, what you can see is k moves ahead. This element is done. This element is done. Now for the fourth smallest element, when k is at index 3, you want to get the fourth smallest element. These two are the candidates and so on. So you can see always and always, we just try to make sure that we have the two best candidates to fill up the position and one of the element we try to pick. Okay. Again, you can see 3 is less than 5. So this is a better candidate. We will put 3 here and we move I ahead. This element is done and we move k ahead. This is 4. And can you see I is done. I has seen all of the possible elements. That means this array is exhausted. This array is now exhausted. If one of the array is exhausted, let's say this array is exhausted, that means all the elements of this array is done. Can I say I can just directly fill in the remaining elements of the other array? Or if let's say this array would have been exhausted, then I would have filled the remaining element of this array. Because why? Because if this is exhausted and these are the two remaining elements, we definitely know that this is an increasing order because both of the arrays were sorted, right? So we will just directly put them here. No need to do any comparison. What we are going to do, whatever are the remaining elements of j, we'll just put it here. We'll put 5 here. We move j ahead. We put 6 here. K also came up here with index 5 and j++. And that's it. Now this array has been exhausted as well. And that's how you can actually merge two sorted arrays. And you can see the final resultant array is of size m+1. Now, the only thing that you have to do in the lead code question is that in the lead code question, for nums1, you have to consider the first m elements for this algorithm. But finally, when you're returning the result, all of the elements of this resultant array, you need to copy back inside nums1. It's just a lead code thing. They have just made it to make the problem complex because there will be 3 more, or I would say n more zeros. So what you'll do, you will put 1 here, you'll put 2 here, you'll put 2 here, you'll put 3 here, you'll put 5 here, and you'll put 6 here. Okay. So let me code this solution, and then you'll get a better understanding of how the lead code platform expects us to submit the solution here. But before that, are you guys able to understand what is actually going on? Let's code it first, and then we'll discuss the time complexity as well. Okay, so let's try to code this question. Okay, so I'll be coding it in Java. This is the function that we have to code. Okay, public void merge. So you can see there is a nums1 array and there is a nums2 array. We have been given m and n. M and n represents the number to consider, but actually nums1 array is of length m plus n, right? Actual length of nums1 is m plus n, which we will use to store the final result. Okay, cool. Now let's start. First of all, we'll get a variable I equals to 0, j equals to 0, k equals to 0, right? We need 3 variables. Okay. Now, Nihal, is this your first class? What do you say? Nihal Sandhu, is this your first class? We already discussed, right, that we'll be coding some questions in JavaScript, some questions in Java. Remember? Again, guys, I'm explaining. It's been 3 times, but again, I'll explain. JavaScript is slow in online coding tests. There can be a case that you submit a solution in JavaScript and it will give you time limit exceeded because it's very slow. Although the code of Java and JavaScript is very similar, but Java runs very fast as compared to JavaScript. So to make sure that you guys are not at a disadvantage, I'm coding the solution in Java as well. If you guys don't know Java, then 4 or 5 classes back, I shared you a resource to revise Java as well. Okay, so please do that. It's for your use case. If you don't want to use Java, I'm okay. Use JavaScript, but if you, in case you are stuck, you have to handle it yourself. No, there's no provision of that. If you want to code in some other language, if you like C++, you can code in that. If you like Go, you can code in that. I do not have a problem. Okay, now let's start. So now what we are going to do is, what we have to do is we have to run a loop. We have to run a loop on both of these arrays. So let me show you how I will do that. I will say while I is less than m and j is less than n. That means till the time either nums1 array is not exhausted or nums2 array is not exhausted, right? What I'll do is I'll compare. If nums1 at I is less than or equal to nums2 at j, okay? Then what we're going to do, we need a resultant array. So let's make a resultant array, int result. Let's make a resultant array. And how do you make array in Java? You say new int of size m plus n, right? You can see this is a resultant array. What I'll do is I'll say result of k is equals to nums1 at I. And then I will move k ahead and I will move I ahead. Else, we'll say result of k is equals to nums2 of j. And I'll move k ahead and j ahead. Can I say that? Right? That's what we have been doing, right? That if 1 was less than 2, we put 1 here and we move I ahead and k ahead, right? That's what we are doing here. Now, what do you think? When will this loop end? This loop ends when either I becomes equals to m or j becomes equals to n. Can I say that? If I becomes equals to m, that means nums1 is exhausted. And if j becomes equals to n, that means nums2 is exhausted. Can I say that? Very simple. Right? If I becomes m, that means all the elements of nums1 are done. And if j becomes n, then all the elements of nums2 are done. So if all the elements of nums1 is done, we have elements left in nums2. Let's fill that directly. Okay. Okay, cool. Let's do that. So we'll say while j is less than n. I'll do this. Can I say that? Can I say that? Right. That means because I become equal to m, j was still less than n. So till the time j is less than n, keep on picking up the elements from nums2, put it in result, k plus plus, j plus plus. Why k plus plus? Because you still have to move to the next index of result to get the desired output at the correct place. Otherwise, if j is equals to n, that means we have elements left in nums1. Let's fill that directly. How do you do that? We'll say while I is less than m, and I'll just copy paste this. Because we don't have to do a comparison, we'll just directly put it here. Okay. And finally, when all three loops are done, these three loops are done, we have the answer inside our resultant array. One more crucial thing to note here is why you need an AND condition here, because till the time you have elements in both of them, only up till that time only, you can actually compare them, right? You will be able to compare elements from nums1 and nums2 till the time you have elements left inside them, right? If any one of them is exhausted, you cannot compare. Then you have to just directly fill. So that's why we need an AND condition that both of them should be having an element left. Now, finally, in general scenario, you could have returned result. But LeetCode doesn't expect us to do that. What LeetCode says is that copy the answer of result inside nums1 because actual length of nums1 is m plus n. So what you do is you again make k equals to 0 and you say while k is less than m plus n, nums1 at k is equals to result of k and k plus plus. So what I'm doing is I'm iterating on result and I'm copying all the elements of result inside nums1. And that's it. That's what LeetCode expects us to actually do. That is it. Make sense, everyone? Just a second, let me open the LeetCode account again. Any questions till now? Any questions with this algorithm? How will you do that, Amit? Sure. Okay, so in that case, you are reading from behind.